Cream Academia. This is your third lecture on differential calculus, and today we will be discussing about inverse and composite functions. Okay. So first we will see about the definitions and the basics, and then we will move on to the questions. So first we will discuss about composite function. So let's see the definition, which says that a function composition is an operation that takes two functions f and g and produces a function such that h of x equals to g of f of x. Okay. So from these sets or the Venn diagrams, you can see that suppose there is a set A and it has not only one element, it has suppose 10 or 15 or a finite number of elements, okay, which is termed as X. B is another set which has elements such as Y1, Y2, which is as a group termed as Y. And in the set C, you have elements Z1, Z2, Z3, so on, which are termed as Z. Now, suppose I define a function f. F is a function which maps x to y. Okay. And g is another function which maps b to c. Now, if I make or define another function h which will map a to c, then this function h is a composite function of f and g. Okay, you can see here from here that y is equals to f of x, which is mapped by the function f. Z equals to g of y. Here you see z equals to g of y because the function g is mapping. So you can write z equals to g of, and y is equals to f of x. So you can write z equals to g of f of x, which is also written as g o f of x. So z is defined as a function h of x, which is a composite function of g and f. Fine. Now next, that is a composite function, and you will have only basic questions from this. Okay. Next, inverse function. So in the previous lecture we have discussed about surjective and injective functions, onto and into, and one and many one. So a function, I've said you in the previous lecture only that a function which is both onto and one, that is both surjective and injective, is a bijective function. Okay, and only those functions which are bijective, they only have their inverse. Only those functions have their inverse. So here you can see that suppose f is a function and it is a bijective function, then it will have an inverse which is termed here as g. So g is the inverse of f, and you can write g is equals to f inverse like this. This is the symbolic representation. Okay. Now, since g is the inverse of f, so g of f of x will be equals to x. This is a very important result. You should very much remember this thing because this questions comes on this formula. Okay, so g of f of x equals to x if g is the inverse of f. Okay. Now, one more thing, that in an inverse function, the range of the original function becomes the domain and vice versa. That means you can see from here that for g of x, the range of f is becoming the domain, v is the domain, and the domain of the function f is becoming the range of the function g. So it is vice versa. Okay. Okay. So now we will start with the question solving. So the first question is on inverse function itself. Okay, you can see that it is given that f of x equals to x squared plus 1. So you have to find the value of f inverse 17 and f inverse minus 3. So for this, first you have to find out the function in terms of x. the inverse function. So how we will do that? See the steps. First you will take one variable y, okay, because y equals to f of x, which is equals to x square plus 1. So now I will express the equation in terms of y. I will express x in terms of y. Here y is expressed in terms of x. So I will express x in terms of y. I will write like this. X equals to plus minus under root y minus 1. Now in this question it is only given that f of x is a function, no domain or range has been specified. So the inverse can be either the positive one plus under root y minus 1 or minus under root y minus 1. Okay, we don't know, so we will take both because in the question nothing is specified as such. Now we have got this. So now from here what you will see that y equals to f of x. So if you take inverse on both sides, then what you will get? X equals to f inverse y, because f inverse of f of x is x, as we have seen from this property over here, isn't it? So x equals to f inverse y, so I will write f inverse y equals to plus minus under root y minus 1. Now if I just replace the variable, if I replace y with x, then I can write this as f inverse of x equals to plus minus under root x minus 1. So I have got my function f inverse of x. Okay, now I will just put the values and see. So first value was for f inverse 17. F inverse 17. So I will put 17 in this equation. So I will get plus minus under root 17 minus 1, which is 16, plus minus 4. Okay. Next is f inverse minus 3. Now in this equation, since this is a square root, minus 3 is not possible. It will give imaginary number, under root minus 4. It would be equals to plus minus under root minus 4, which is equals to plus minus 2 iota, imaginary number. So, and since in this question it is not also defined that whether the function is a real valued function or not, so it can happen. Okay, this is not false, this can happen. Okay, a value can come like this. So we will see the options what is given: 4, 1, 4, 0, 3, 2. None of these are matched, so the answer would be none. Okay, so you have understood how to solve questions with inverse. Okay, this is the basic trick of converting the function and finding out your inverse. Okay, like this. Fine. Next question. Next question is a question on composite functions. Okay, composite function questions are very easy, but also very basic questions which can come in WebGEE. Okay, so it is given f of x equals to 1 minus x by 1 plus x. Then you have to find f of cos 2 theta. Okay, first I will find f of cos 2 theta, which will be equals to 1 minus cos 2 theta by 1 plus cos 2 theta. Okay, now if you know basic trigonometrical transformation of multiple angles, 2 sin square theta. Okay, and 1 plus cos 2 theta can be written as 2 cos square theta. Okay, so this is cancelled and this would be tan square theta. Fine. Now again we have to find f of cos 2 theta. So f of cos 2 theta would be f of tan square theta, because cos 2 theta is tan square theta. So this is after putting the first operation, and this is second operation. Okay, so I will put tan square theta in place of x, 1 minus tan square theta by 1 plus tan square theta, which is equals to how much? Cos 2 theta. cos 2 theta in terms of tan theta. So you can see that whenever you are giving any competitive exam, you will not get question from a particular topic only. Questions will be always mixed. Trigonometry will be used in calculus, algebra can be used. So you should be thorough with each and every topic. Only then you can solve the question. Okay, so I have got f of cos 2 theta equals to cos 2 theta only. Fine. So option C. So in this question a composite function तो था ही, उसके साथ जो मेजर था इसमें वो है trigonometrical transformations which you should know very clearly, otherwise you cannot reduce it to the simple forms. Okay, fine. Okay, this question came in WebG 2016 and this is a multiple correct question. Okay, multiple correct. So let's see. Okay, now function f is defined on the set x such that f of x equals to x for all x belongs to x. All small x belongs to the capital set x, and x, the set x is a subset of real numbers. Okay, so I can say that this function is a real valued function. So you can see there are 4 options and this is a multiple option correct question. So I will start from the thing that has been given in the question. f of x equals to x. Okay, now if I take f inverse on both sides, okay, then it would be f of x equals to f inverse x for all x belongs to the set x. Now for all the values of x, f of x equals to f inverse x. That is the value of the function and inverse is same for all the values of x, which means that inverse exists. Inverse exists for f. Now since inverse is existing, that means your function is bijective, otherwise your inverse cannot exist. And since your function is bijective, that means your function is both surjective and injective, which is onto and 1 1, isn't it? So you can see that how this one equation f of x equals to f inverse x is telling me that my function is onto and 1 1. I am deducing this from this. Okay, so you can see the options that a is correct, f is 1 1 and f is onto. Okay, so option A and B both are correct. Okay, A and B both. And this sort of questions carries 2 marks in your WebG. The single correct ones are 1 marker and these are 2 marker questions. So if you can get correct both the options, you get 2 marks. Okay, so that is more beneficial. Okay, next question is also from WebG 2013. So this is a question on composite functions. You can see what is saying that f of x is something given and g of x is something, and then you have to say that whether this equation, after solving this equation, the set of real numbers x is what, empty, or the set is empty or singleton or whatever. So first you have to solve this equation, f of g of x equals to x. I will solve it like f of g of x. Okay, so what is f of x? 2 to the power 100 x plus 1, that is 2 to the power 100 x g of x plus 1. equals to x. Now I will put the value of g of x, that is 2 to the power 100 into 3 to the power 100x plus 1 equals to x, or x equals to, okay, 2 to the power 100 and 3 to the power 100 is 6 to the power 100x plus 2 to the power 100 plus 1. Now after taking x common, I get 2 to the power 100 plus 1 by 1 minus 6 to the power 100. So you can see that after solving this equation, I am getting only one value of x. Okay, this is a particular value. If you calculate this, something will come. Okay, so I am getting only one value of x. So my set x will have only one value, that is x equals to this, which is something, let's say k, any constant k. So my set of x is only containing one single element, that is k, every time. Okay, so that means the set is a singleton set. Singleton set means a set which has only one element. Okay, cool. So this was an easy question, and other options are finite set with more than one element and infinite set. So these are wrong. This is a singleton set. Option B. Okay, next question. Next question is again on inverse functions. Okay. Now, okay. So G, it is given that G is the inverse of f. Okay, G of x is the inverse of f of x, and f dashed x is equals to sine x. Then I have to find the value of g dashed x. Okay, so whenever you have been given this kind of questions, if the pattern is somehow like this, then you have to take that basic equation of inverse, the basic equation which I said in the beginning, that if g is the inverse of x, then g of f of x equals to what? X. Fine. Okay. Now I will write that g of x equals to f inverse x. Fine. G of f equals to f inverse x. Then f inverse of f of x equals to x. Now f inverse of f of x equals to x. Now if I do a bit of changes in this equation, then I can see that if I write f of f inverse x, that will also give me x, isn't it? F of f inverse x will also give me x. So f of g of x equals to x. Now I will differentiate both sides. Okay, now I will differentiate both sides. Both sides with respect to x. So what I will get? I will get f dashed g of x into g dashed x equals to 1. Okay. Now, what has been given in the question? It is given that f dashed of x equals to sin x. F dashed of x equals to sin x. तो f dashed of g of x क्या होगा? It will be equals to sin of g of x, isn't it? Sin of g of x. So f dashed of g of x would be sin of g of x into g dashed x equals to 1. So what I will get? I will get g dashed x equals to 1 by sin of g of x which is equals to cosec. साइन का ऑपोजिट इनवर्स क्या होता है? कोसेक. कोसेक ऑफ g of x. सो g dash x is cosec of g of x. ऑप्शन में है क्या? हाँ है, ऑप्शन बी. ऑप्शन बी इज द करेक्ट ऑप्शन. सो व्हाट इज द बेसिक आइडिया कि अगर आपको g dash x क्या है? दिस g dash x इज बेसिकली f इनवर्स x का डेरिवेटिव है ना. So whenever you have been given to find out the derivative of f inverse x, then you will use this equation, this one, star marked. And whenever you have been given to find the derivative of f of x, you will use this equation, because if you derivate or differentiate this one, you will get f dash x, and you can find f dash x directly. And in this case, if you differentiate, you can find f inverse x dashed. So you can find the derivative of f inverse x directly. So both these equations are correct. Okay. And according to the question, you have to use your brains and find out and think which equation you can use so that you can just get the answer in few minutes.
Few minutes, not few seconds. Because I have done a lot of steps to explain, but in the exam you will not do so many steps because you have less number of time and more number of questions. Okay. So this is for today. We have done good questions. Try to practice questions which are there, which came in the previous year. Okay, so that you can get a good idea. You can solve them and keep practicing so that you can get a good score. Okay.